Okay, so we'll be going through the chapter on your scalars and vectors itself. Now, some schools will teach it at the very start of the class. Teach it at the start of the year. Some will only teach it after kinematics or after dynamics itself. So your scalars and vectors itself basically are your physical quantities. That's why it's usually taught in your first chapter itself. So what exactly is a scalar quantity and what exactly is a vector quantity? So first things first, scalar quantities only have magnitude but no direction itself. So which means that they only have your numbers and your units. So for scalar, you want the number, which is your magnitude and your unit. Okay, so to be more precise, this is actually your magnitude. Okay, and then on the other hand, your vectors itself, your vector quantities have both your magnitude and your direction. So if you ever want to answer a vector, like your answer is a vector, normally what we will have is your magnitude, which is number plus your unit and your direction as well. Okay, so let me just write this. My handwriting is not very good, but basically magnitude, unit, and direction itself. So you can see over here, you can see that at the end of your answer itself, you want to mention whether it's to the left, to the north, to down, to up, right, up, down, left, right. Okay. So now, if you have covered your dynamics chapter already, basically you know that your forces, which is a vector, see over here, your force is a vector, they will actually be represented by arrows. And these arrows, the very, very important is you need to know the length of your arrow, which shows your magnitude, how big is my value. If I have a 50 newtons longer than a 10 newtons, for example. Okay, and the direction of the arrow that you point at is the direction of your vectors. So you can see actually for all vector quantities itself, we actually use arrows to actually denote how big they are, by how long they are, and the direction that they point to is the direction of the vector itself. So the thing is, when you add two vectors, you need to consider both the magnitude and the direction itself. So the thing is, if you add two vectors together, it can be same as if I add these two vectors together, they will give me a single vector that is the sum of the two. The sum of the vectors is called your resultant vector. Okay. So if I say you have a force of 20 Newton and then you have a force of 10 Newton here. Okay. So this is also the same as saying that you have a force of 30 Newtons. Can you see that? Because if you just add up the two forces in the same direction, you can present it as a single vector, which is 30 newtons. So this 30 newtons is what we call your resultant vector itself. It is the sum of these two vectors. Okay, this is the most basic version of a resultant vector. So if you have done your dynamics, you know that usually we will do it in either horizontally or vertically only. We don't mix them together. But for this chapter itself, we're going to learn what to do if we end up with a horizontal and a vertical vector itself. How can we add them up to find your resultant vector? So as I was saying, so if you're doing your dynamics or you have not covered your dynamics itself, basically what we want to do is you choose one direction to be positive. So if they are both in the same direction, both of them will be positive. You can just add them both up. So these are forces, right? So you just take 5 plus 3 and you end up with 8 newtons. And this is 8 newtons to the right. Okay, so you can see over here, this is 8 newtons to the right. And if you notice, normally for a single vector, we have one arrow each, right? But for your resultant, because it's the sum of two vectors, you actually have two arrows. So for resultant vectors itself or resultant force, you actually have double arrows because you're adding up two different vectors. Okay, so how do you show it? Just write double arrow. So same thing. Now, if you have two vectors in opposite direction itself, what you want to do is either you take the bigger one to be positive. Normally, what side is positive depends on the direction that we are moving itself. So if you're moving towards the right, we will actually just write resultant force. It's just 5. And because your positive, your 3 is in the opposite direction, we actually minus it away. So you end up with 2 newtons to the right. Okay, so basically you can see in the over here, your resultant vector is the sum of your forces, just that some of the forces that we are talking about has a positive or a negative value itself. So you can see that you have single arrow, and end up with double arrows. Okay, so basically this is how you solve it. And if they are exactly the same, you will just say that your resultant force is 3 minus 3, you end up with 0 newtons itself. Basically, just remember resultant force is 0, you are either stationary, your forces are balanced. Okay, you are stationary or moving at constant speed or constant velocity. Okay, so do take note. Why? Because sometimes the question will tell you that you are stationary itself, so you need to work backwards to actually calculate the values. Okay, so how are we supposed to draw your vectors itself? So first things first is that you need to prepare all your drawing materials, your pencil, your ruler, your erasers, and all whatnot. Okay, so first things first, how do we draw a single vector? So this drawing that you see here, these steps, right, is to draw one vector. Okay, so first thing is you want to draw velocity in this direction itself. Now, if you see this 45 degrees north of east, you don't need to panic first. Okay, I'll explain what it means later. So first things first is you want to always choose an appropriate scale first. So based off the amount of space that you're given, for example, if we are only given this amount of space, okay, if we only have this amount of space, you need to get your ruler. Now, my ruler itself, because I'm using OneNote, it doesn't have a scale itself. So what doesn't have like numbers to denote how big or how small. So some of the drawings you see in my in the notes itself, like when I draw it myself to show you how to draw, it won't be to scale, but you have to draw it to scale because this is very, very, very accurate to score marks. You need to draw it properly and precisely, otherwise you'll lose marks. Okay, so you can see over here, if you want to draw about 4 cm itself, 4 cm falls just nice within this space that you have. So basically what you want to do is you want to choose a proper scale. So the first thing is you want to choose a proper scale. Now, take note, don't write like this. Write 1.0 cm is to 5 meters per second. Okay? Or you can write 5.0 meters per second. Basically, what you want to do is make sure that the scale that you use here is always the smallest number. You always put your scale, right, with a 1.0 cm on the left-hand side. Because using a ruler itself, the smallest division is your 0.1 cm. So all your answers for when measuring with a ruler must be 1 decimal place. So same thing basically for this, you want to use the space given to you to actually draw your diagram itself. Okay, so we'll use 1.0 cm to represent 5.0 meters per second. So first things first, what you want to know is, okay, going back to the direction itself. 45 degrees north of east, that means from, okay, I'll just write it over here. Okay, some schools will actually phrase it differently itself. Okay, what does it mean? Means from east, it is 45 degrees to the north. So what I mean by this is, so first thing, you can see that we are using from east, correct? So because, okay, maybe I'll use a different color. So from east, right, what you want to say is, from east means from the horizontal line. So what the very first thing you want to do is you want to draw a horizontal line using dotted line. Okay. Now this dotted line is not your vector, it's just a construction line to help you draw. So this, what I'm talking about, is the baseline that we have. Okay. So why do we need to draw the baseline itself? It's actually for us to identify where do we draw your angle, where do we measure my protractor from. So what you want to do is just grab your ruler and you want to dot horizontal lines. Okay, so the next thing is 45 degrees north of east. So from your east, which is your horizontal, what you want to do is you want to take a protractor and measure 45 degrees. And you want to measure 45 degrees. Normally we have to mark it somewhere, right? Something like this. So the very next thing is, now this question tells us that your velocity is 20 meters per second. So using back my scale, if this is 20 meters per second, I must represent it as a 4 cm itself. So I represent it as a 4 cm. So I'll draw 4 cm arrow. Okay, and for my answers here, what I'll do is I'll write 4 cm and then I'll write 20 meters per second. So this is how you draw your vector. So only the purple line with the arrow, the purple arrow, that is your vector itself. So that is your one vector. So you want to write like this. Now, just now what I mean by the direction, right? Not all schools will actually present it this way. Some schools will actually phrase it as is 45 degrees from the horizontal. Okay, so instead of saying using north, south, east, west, they actually use vertical, they use the horizontal, they'll use this. Okay, or it'll be 45 degrees above the horizontal. This is what they mean by this. So you need to double check your school notes. So the thing is, in most of the recent papers that I've been seeing itself, most of the schools have been using based off the horizontal, the vertical, or from another or from your vectors itself. So you need to double check how does your school phrase it. So in this one, I'll try to phrase my answers according to the horizontal and the vertical ones accordingly. Okay, so this is just to draw one vector, right? So the problem is normally we will be dealing with two vectors. Okay, so first things, let's double check. Now, if your vectors are very, very nice, okay, what I mean by very nice is they're all perpendicular, 90 degrees, very, very nice shape. What you can do is you can use Pythagoras theorem straight away. Okay, but if question tells you, right, if the question mentions skewed diagram, then you cannot use Pythagoras theorem. Okay, if they say with the use of a skewed diagram, that means I cannot use Pythagoras theorem. I can use it to double check my answer, whether it's correct or not, but I cannot use it to solve for my resultant vector. Okay, so do take note about this. So how are we supposed to draw your resultant vector? How are we supposed to find your resultant vector? Okay, so this is what we call your head to tail method itself. First thing, we have number one vector, we have number two vector, and then from your here to here. Okay, so what I mean by this is, for example, now if let's take the one on top here. Okay, so even if it's a very nice Pythagoras theorem, like a right angle triangle, right, we can still make full use of this as using the head to tail method. So let me guide you through. So number one, what you want to do is identify you have a 3 cm here. Okay, and number two, my second vector is a 4 cm like this. Okay, so what you want to do first is always pick the easiest diagram to draw. Okay, now do take note, right now what we are doing is just a sketch. It is not the actual drawing. So use a pencil and you want to always extract out what are my two vectors first. Okay, so because what you end up with will be, okay, so I have this, right? So first thing is just first diagram, I will draw like this. Okay, it's going to be a horizontal and this is a vertical itself. So what you can do is you can take a protractor, make sure it's 90 degrees and you draw upwards, 4 cm. Okay, so what I mean by head to tail method is, number one, we always draw your first vector first, number one. Okay, draw your first vector. So from the tip, from the head of my first vector, I will draw my second vector up. Okay, then from the tail of my first vector, so over here to the head of my first vector, I will draw a single line through, and this line, you can see my arrows, right, is moving from right up, and therefore it's gonna be a diagonal right up. Okay, so you can see this is my resultant vector. How this works, basically it's kind of like a treasure map. You're kind of guiding somebody through, right? So it's like taking a shortcut. So you know that the path to your end goal, okay, this is the start, this is the end, right? So by right, if you go by logic, okay, I need you to go to the east and I need you to go to the north. So if you want to take a shortcut, what do? We just take a path straight like this, right? This is your shortcut. So basically, you can imagine your resultant vector as your shortcut. You must always start at one point and end at one point. Okay, you cannot start at 2 points and at 1 point, or you cannot start at 1 point and at 2 points. You must only have one start, one end. Then we just draw a straight line from start to end. That's all. Okay, so you can see in the diagram over here. So I have my vector number one over here. And if you notice, this is a diagonal, correct? So the thing is, if we are dealing with diagonals itself, the very first thing we do is usually, whenever we have a diagonal, there usually will be an angle. Okay, there is usually an angle here. All right, then usually for the second vector, there's going to be another angle as well. So we always need the baseline for diagonal arrows or diagonal vectors itself so that we can identify which side we use. Now, when do I use a vertical baseline? When do I use a horizontal baseline? It depends on the question. If the angle that they give you is from the vertical, we use vertical. If the angle that they give you is from the horizontal, we use the horizontal itself. Okay, so it'll make more sense when we start doing the word examples. But for now, just take it as it is. Understand how this works. If I start here, I will end here. So I will just draw a straight line from start to end, and I'll draw double arrow. This is my resultant. Okay, so basically my blue and my yellow, if they add up, they'll give me the green. Because if I follow the path, I start here, I end here. So same thing, if I want to draw a vector, I'll have to start here and end here as well. Because 1 and 2 basically means I'll travel in this path. That's all. Okay, your parallelogram method is actually a much more safer kind of method to actually solve your questions. But because it actually has a bit more steps that you want to take, it's a little bit more troublesome. So number 1, number 2, you have your two vectors, right? And you notice they both start at the same point. So the problem is if they both start at the same point, okay, you cannot draw. Okay, so basically what you want to do is if you both start at the same point, you will take two different paths. First, number 1, I'll take two paths. Okay, so what I mean by this is sometimes you see a question that they tell you that you have two vectors over here, vector 1, vector 2, correct? So a lot of students, oh, 1 and 2, I just need to connect the dot, close the dot. This is wrong. Okay, this is totally wrong. So what we want to do is, number 1, we always split them apart first. Number 1, we have a vector here. Okay, number 2, we have a vector here. So you want to add them up. Okay, so what you want to do next is you just want to find your resultant, correct? So I'm going to pick one of the easier ones. So I'm going to pick number 2 here. And if you use head to tail method, I'm going to start from here. I will draw my number 1. Okay, then from start to end, I will just draw like this. So this is head to tail method, correct? So for your parallelogram method, what we do is we're going to drag this guy. Okay, we're going to mimic it on the other side. So you have number 2 over here. And once you draw it like this, what you're going to do is from here, I'm going to draw number 1. So basically, you just want to mimic on both sides. You must form a parallelogram. Okay, then from start to end, you can see that your end is here, your start is here. You will draw your resultant vector and you'll end up with the same diagram. So basically, right, if you take this and this combine together, you get your parallelogram. You see, if you cover the bottom, okay, if you cover on top, can you see this is your head to tail? And if you do the other side, you'll notice that, hey, this is another head to tail. So your parallelogram is actually made out of your two head to tail methods. So yes, it's a little bit more troublesome because I need to draw this, I need to draw that, and especially if you have a lot of diagonals, I need to draw baselines and angles for each and every one of them. So very, very troublesome. So a lot of times your schools will actually just teach you head to tail method and that's it. Okay, now I want you to take note. Anything that you use to measure, whether it's your length, whether it's your angle, whether it's your baseline, all must be drawn and labeled properly with their values inside your diagram. Okay, and your arrows matter. So if you don't draw the arrow or you draw it wrongly, -1 mark. You never show the angles, the values of your angles and where you measure it from, -1 mark, and so on and so forth. So just be very, very careful whenever you're dealing with vector drawing. Okay, so now let me elaborate on your work example. So the thing is, number 1, we have two forces. We have this 700 and we have this 850 over here. Okay, and they tell you that your angle between them is 40 degrees. Okay, so using a scaled diagram, you can see over here, a scaled diagram, right? Determine the magnitude of your resultant force. So basically what we are trying to find is your resultant vector. So before we go crazy and do anything, okay, very first step, when we want to dissect the question, okay, not the step to draw, when we want to dissect the question, first thing you ask yourself is, I have two vectors, right? Number 1 vector. Number one vector is this 850 over here. Okay, what's your number two vector? Number two vector is I have this 40 degrees and this is a 700 Newton. Okay, so you can see now because I have the proper values, how I sketch. Okay, so these two that you see here at the side, those are all sketches. Because the thing is, one thing you'll notice later on when we actually start solving, right, is you need to do a quick sketch to know the shape of your graph, shape of your diagram, right, so that you can choose the most appropriate scale. Because some students, you'll notice that they never plan properly. They end up using too much. A scale that is too big or too small itself, you will minus marks. You must fill up 3/4 of your space. So if your diagram is very, very small, very, very cute, very, very small, no marks to you. If your diagram is too big and it exceeds the paper or touches the question, you might lose marks as well. Okay, so you want to choose a just nice diagram itself. So we always draw the one that is easiest first. We will draw this 850. Okay, maybe I'll use the colors to show you. We'll draw this 850, and from this point, I'm going to draw dot, dot, dot. And you notice this is 40 degrees from your horizontal, right? So you want to measure your 40 degrees, and you want to draw this 700. So you can see one start, one end. What you want to do is you want to just draw like this. This is your resultant force. Can you see that? So basically, you can see that the rough shape looks like this. So it's more of an elongated from the bottom left to the bottom right, to the top right. Okay. So first thing you ask yourself, okay, the space I'm given is quite big, correct? So I want to choose an appropriate scale. So you look at your numbers. You have 850, you have 700, and if you notice your purple color one, the purple one is slightly longer than your 700, 850, right? So what you want to choose maybe is I'll choose something that's about. So just remember the longest length must be less than your 15 cm ruler. Anything longer than that, you went too far. Okay. So you always want to make sure that the vectors that you're measuring itself is roughly 5 to 10 cm. Okay. So if it's not 5 to 10 cm, something will be wrong. So what you want to choose is, for example, I'll choose this. Now do take note, don't write 1 cm, we take 1.0 cm. Okay. So the very first thing we want to do is right at the side. My scale is going to be 1.0 cm is to 100 newtons. Okay. So now is we want to draw. So you can see if we sketch based on this, we should sketch from the bottom left. Because if we sketch from the top or in the middle itself, we draw here, what happens is if we, okay, so you just imagine I just draw like this, it's not going to be very big. Okay, you'll notice that the space I take is less than the full page. So what you want to do is make sure that you draw according to this. So you have make full use of the space itself. Okay, so as I remind you once again, because I do have numbers on my OneNote ruler, I will just draw a brief estimated value. Okay, so you can see over here, first thing you want to do is you want to make sure that this is your 800 newtons, this is 8 cm. Okay, you want to draw this is 850, right? So let me just rewrite this. This is 8.5 cm. This is 850 newtons. Okay, so this is my vector number one. So from this point, the tip, the head of my second vector, what I'm going to do is I'm going to draw a baseline horizontal. So what you want to do is measure your 40 degrees. Okay, you want to measure your 40 degrees over here, and you will want to draw a line. Remind yourself, this is 40 degrees. You want to draw 700 newtons. Okay, 700 newtons itself. So 7 cm equals 700 newtons. Okay, now remember, this is not to scale, all right? So it could be bigger, could be smaller. Make sure that you just have enough space. So what you want to do next is from the start to the end, you want to draw solid lines, okay? From start to end, all the way through. And because this is a resultant, you want to draw the up arrow. Red plus blue give you purple, okay? So what you want to write is your resultant force. Okay, is what's the value? Let me check values. You should get about 14.6. Okay, so 14.6 cm, and you want to change it to 1460 newtons. Okay, based off the scale that we are using itself. So using this, we have found our value over here. Okay, so now if you take note, the question just asks us about the magnitude, right? So magnitude-wise, answer is 1460. Now, if the question ever asks us about the direction, what we want to do is we're going to take this angle here. Okay, so if you measure this angle, for example, okay, because mine is not accurate, I'm going to use the one that I have drawn properly, that is slightly to scale. So I'll just measure this. This angle is about 18 degrees. Okay, so what I mean by this is this angle here is 18 degrees, right? And because it's 18 degrees, how would I phrase my answer itself? So the answer, how I phrase it is that my resultant force is equals to 1460 newtons. Okay, 1460 newtons, and I'll write 18 degrees. Yeah, let me just. Okay, 18 degrees above the horizontal. Okay, or you can also say 18 degrees from the 850 Newton force. Also can. Both method works. Can you understand? So basically, you just want to have kind of a reference point that the teacher can understand what you mean from that. Okay, so you can write, this is your final answer over here. Okay, so to just make things clearer, most of the time you have your drawing somewhere in the middle, and you will have this, and this is the answer key. So basically, you have this part. Okay, so you can see my diagram itself, not exactly to scale, but you have all the necessary parts that you have. You have my first vector, you have my second vector, you have all the angles that we have been using, and we draw from start to end. Okay, so this is how we draw a vector diagram. Okay, so let's take a look at another example over here. So sometimes the question won't be so nice to give us a diagram itself, so we need to pick out the words. You are flying towards the north and you have a velocity of this. Okay, and then next, number 2 is I have a strong wind blowing at 8 at northwest. Okay, so you can see these are your two vectors. You have number 1, you have number 2. Okay, and next, using a scale diagram. So cannot use Pythagoras or anything like that. You want to find your resultant velocity and the direction itself. So number 1, first thing, remember, before we start solving or using any scale, the very number 1 thing we want to do is ask ourselves, number 1, what is the direction? You have this 75.0. Okay, and number 2, what do we have? We have this northwest. Northwest is in this direction, and northwest, if you realize, it's going to be 45 degrees either side. So you can either use your vertical or your horizontal to draw your 45 degrees. So these two will add up and give me something. So we always draw the simplest one, which is usually this. And number 2, what we want to draw is something like this, and you want to use 45 degrees. Okay. Now, if you notice, I didn't use my horizontal, right? Because if you notice, if I'm going to draw my resultant, it will conflict. It will overlap. So a bit messy. So I'll use the vertical instead. So you can see this is my resultant. Okay, resultant velocity. So you can see the shape is a bit long. So we have to start most likely at the bottom or bottom right itself when we start to draw. So now, same thing. You ask yourself, the numbers is 75 and 80. So what you want to do is choose a proper number. You roughly will use 10.0. Now, if you notice, all the values here is 3SF, right? So my scale, I'll also follow according to this. I'll use 3SF on the right-hand side as well. Okay, so you can see over here, I have a lot of space. So the number 1 thing is we want to do is we just do a quick sketch. Oh, before we do a quick sketch, I almost forgot. We are supposed to write the scale. So 1 cm, we write 10.0 meters per second. Okay, so I'm going to draw on the right hand side. Over here, I'll draw. How much is this? This is your 75, right? So I'm going to use 7.5 cm is equals to 75.0 meters per second. Okay, so same thing. We'll draw the easiest one, and the next thing we do is from the head itself of your first vector, what we want to do is we want to draw dotted lines, and you want to measure that 45 degrees itself. Okay, you measure that 45 degrees. What the first thing you want to do is you want to draw a line to show that this, how much is this? This is 80. So what you want to do is 8 cm. So you have 80.0 meters per second. Okay, so you can see obviously they are not to scale itself. So what you want to do next is just make sure that you draw from head to tail over here, from head to tail, have a rough quick sketch all the way through. Okay, now because just remember is mine an estimation, not a proper one, is because I do have values on my ruler itself. Okay, so your resultant velocity should answer the question back, right? How much is it? You will notice that the value is 143. Okay, so basically it is 14.3 cm. So I end up with 143 meters per second. Okay, and you notice I don't write the 0.0 anymore because this is gonna be 3SF. Okay, and what you want to do next is to find the angle itself. So same thing, we're gonna use this angle, we're gonna find this angle. So for me, the angle would be roughly about 24 degrees. All right, so how do we answer this question? So we are supposed to just write resultant velocity equals, the value is 143 meters per second, comma, and we're going to write 24 degrees. Okay, 24 degrees, we're going to write left from the vertical. Okay, or you can also say 24 degrees left of the 75.0 meters per second as well. Okay, the phrasing is a bit funny, but basically you just want to say something like this so that the teacher understands where you are coming from. Okay, so most of the time we just use from the vector, from the vertical or from the horizontal itself, above, below, to the left, to the right, whatsoever. Okay, so in this case, this is our answer here. Okay, that's it. Questions? Okay, so if there's nothing else, then we'll actually, so at this point, if you're still unsure about this video, about how to draw itself, go back, rewatch the video again. There is still another part, but once I introduce it, it might get a little bit confusing. So for now, if you still don't really understand how to draw using these two examples itself, erase it again, try it on your own, okay? So try to do it. Once you master it, then continue on with this part of the video. Okay, so from this part on, now, keywords. If you know it's stationary itself, resultant force must be 0, okay? So if resultant force is 0, your sum of force is 0, correct? So now, if we take a look at this tree, okay? Now this tree, they are all vectors. There's no resultant right here, okay? So now, let's say I pick number 1, number 2, and you have number 3, right? So let's say we take number 1 and number 2. So we take number 1, and we have number 2, right? You have number 1, and you have number 2, and you notice these are head to tail, right? So how do we draw? We will draw your resultant vector, and we will draw from start to end. You'll notice that it's in this direction. This is your resultant, right? Now, if I want to have no resultant force, my resultant force, if I want it to be 0, what happens is I'll introduce another vector that is going to be exactly the opposite direction itself. So using this vector, okay, this vector, the green one, okay, I will basically put it in the exactly equal and opposite force. And you'll notice that, hey, if my resultant force, okay, so now just imagine now, I have my resultant force, which is in this direction, okay? And if I add that, what happens? They will actually cancel out. You end up with 0. Can you notice that? So basically, right, if you have 0 resultant force, basically it means that you will form a closed triangle, okay? When you form a closed triangle itself, you notice that if this is my starting point, I will end at the same point. My start and end is the same. Okay, now if I start here, for example, okay, wait for the thing. So if I start at the bottom left, you notice that if I go one round, I start and end here as well. So the thing is, when you have no resultant force is 0, your start and end will be in the same position. Can you notice that? Start and end will always be the same position. So regardless of whichever vector I pick, if I take number 2 and number 3, for example, I take number 2 and number 3, right? what happens is I will have a resultant vector from the start to the end over here. And if you notice, this is going to be exactly the same as my number one over here, but just opposite in direction. So if I were to fill it back up in this, back to this stage, you'll notice that yes, I will actually cancel the resultant vector that is formed due to number 2 and number 3. So basically, don't need to worry. If there is two vectors, which is very common, usually the next thing they'll ask you is find the resultant vector, or they'll tell you at the start of the question, this object is stationary and they only give you two vectors. All you need to do is, number one, you can either find your resultant first and then you just flip the direction of the arrow, or you can just form your closed triangle to solve it. Okay, so let's take a look at your word example to kind of understand what's going on. So number one, you are suspended. Okay, suspended means I am not moving. Not moving, resultant force 0. So this question is using the three vectors question. Okay, and if you notice, I have strings, and each string have an angle itself. So to the horizontal, right? Now, when you see a string itself, this is talking about tension. Okay, tension. As you can see over here, tension 100N. Okay, and this is 100N, this is 100N. If you notice the direction itself, tension is up here, tension is up here. Okay, now the question tells us to use a vector diagram to scale, so we cannot use any Pythagoras or any calculation itself. We are trying to find the resultant of my tension. So the thing is, you don't need to worry. Question is not asking us to draw the closed loop triangle itself. We just want to find tension. So first thing, if we just want to find resultant, we just go back to the same step. You have tension 1, which is 100, correct? Number 2, I have tension 2, which is also 100. And if you notice, this is the angle is 30 degrees from the horizontal. So when you want to draw your baseline should be drawn. Let me clean this up. Your baseline should be drawn from the horizontal 30 degrees. Because if you draw dotted line here, you'll notice that you have alternate angles. So this guy is also 30 degrees. Okay, same thing for the blue one. This is also 30 degrees if you draw a dotted line here. Okay, so you will want to add these two up and then combine them together. So same thing, just remember, whenever you see the question, the first thing we want to do is break it down. So at the start, what we want to do is always find your baseline first, measure your 30 degrees, then you draw your 100. Then next, on top here, I'm going to draw my baseline, measure my 30 degrees, and I will find this. So if you notice, you will have a start to end. We'll draw it. It will actually be a vertically upwards, 90 degrees. Okay, so this is your values. So you can see, if you draw it like this, we'll probably have to start at the bottom right. Okay, so don't forget, first thing we want to do is ask yourself, what's my scale? Okay, 1.0 cm, and then you just ask yourself, okay, how much space do I have? I have quite a bit of space, right? And if you notice, if I use 1:10, that means this is going to be 10 cm, 10 cm. My value here might also be bigger than 10 cm. So do I have the space for it? Most likely, yes, I have the space for it. So I'm just going to write 10 newtons. Okay, so I'm going to use 10 newtons over here. So first thing I want to do is take your ruler. Oh, by the way, because of your ruler itself, right, sometimes it's a bit hard to draw the horizontal. What you can do is actually take the transparent part of your ruler and align it to the edge of your book or your paper itself. And what you want to do is just measure baseline. Okay, so very first thing we want to do is we want to measure 30 degrees. Okay, do take note it's 30 degrees from your horizontal. So the first thing you want to do is draw your 100, 30 degrees. Okay, so over here, what you want to do is label it. This is your tension. This is going to be 10 cm or 10.0 cm to be precise. And this is 100 newtons, right? So what you're going to do is repeat it on the other side as well. And I will just draw a dotted line and measure the same 30 degrees upwards from the same point. Draw up, and you'll notice that I have 30 degrees here. So whatever angle you measure, right, make sure to always label it, and this is 100 newtons. And last but not least is that if you draw it perfectly correctly itself, you'll notice that the value should end up very nicely. Okay, so it should be a very, very nice upwards, because don't forget start to end, right? This is your start, you end at top. So this value, your resultant force, is going to be, if you notice, is also 10 cm as well. And this will end up with 100. Now, why is this 10 cm over here? Because if you actually draw it properly, this is actually a equilateral triangle. So if you draw it properly itself, you end up with equilateral triangle. So you can see that this is my resultant, right? So do I need the angle? Yes, because they just tell you to find the resultant. Now, if they just say resultant here, you need to have magnitude, unit, and the direction. Okay, so don't forget to answer the question over here. Next thing you want to write is resultant force equals to 100 newtons as well. And you want to say that this is vertically upwards. Okay, there's nothing else you can write but just vertically upwards. Okay, then next part, hence, write down the value of W. So the thing is, if you notice W is weight, right? And weight will always be vertically downwards. So what this means is, if I see this, first thing, my resultant force is 0. So what you can do is, you can straight away say that your weight is equals to the resultant force of the tension. Okay, you can solve this. Okay, if not, you can just write that your total resultant force. Okay, because just now the on top, this resultant force, right, is the resultant force of the tensions. Okay, now this total resultant force is everything add up. So if you notice, I'm gonna take weight minus your resultant force of the, so you end up with just 0 newtons. So W and resultant force above must be the same. They are 100 newtons. Okay, but the direction matters. So weight is 100 newtons, and you need to say it's vertically downwards, because they are supposed to cancel out, so they will have the opposite direction. So you need to be very, very careful about this. Okay, so weight W is 100 newtons vertically downwards, whereas your resultant force of your two tensions, the blue and the red, is 100 newtons vertically upwards. So to cancel off, have no resultant force, no total resultant force, these two must cancel out. So their values must be the same, but they need to be opposite direction. Okay. Okay, so let's on the drawing part already. Now we are moving on to your magnitude of your resultant vector. So this is mostly have to do with your MCQ itself. So if I have this 5 cm, so number one, I have this 5 cm. Number two, I have this 8 cm. Okay, not to scale. So the max I can go, very simple. I'm just going to do head to tail. Head to tail, right? I will just combine these two together. So what is your resultant? Your resultant is from the start to your end, you end up with 13. Okay, because it's just these two add up. And if you want to have the smallest possible value, for example, if we still use the 5 and the 8, if you want the smallest possible value, if you want the smallest possible value, the most easiest thing that we can do is you just change the direction of your, wait, give me a second. You just want to change the direction of your first or your second vector itself. So what I mean by this is, if you were to draw this, okay, what I mean is this, if I start here, 5 cm, and then I'll draw from here, 8 cm backwards. So where's my start? My start is here, my end is here. You end up with a resultant vector of this, which is 3 cm. Can you see that? Basically, you will just end up in opposite directions. You will take 8 minus 5, which is 3 cm to the left. Okay, so this one goes back to your normal horizontal and your vertical itself. So if we ever want to find the range of possible value itself, we will always take the smallest possible value and the largest next possible value. So your minimum, so your max was 13 cm, correct? So your minimum was 3 cm. Okay, this part is typo, is 3 cm. Okay, so basically my range must be between these two values. So if this is an MCQ question, right, they'll just ask you what is a possible value or what is which is not possible for this to find the resultant vector of these two. So basically, right, even if I have this 5 cm and if I have some angle of this 8 cm, right, the resultant will be somewhere here in between these two. The thing is, this resultant, right, cannot be more than 13 cm because 13 cm is when it's totally flat down. And if my 8 cm is flipped to the left, you will notice that the value gets smaller and smaller. Now, do take note, this is talking about all of your magnitude. Okay, we are not interested in your positive or your negative value itself. Now, why? Because ultimately, for vectors, all vectors, the plus and minus when we use in your structured questions, when we do calculations, right, just mean direction. Positive direction, negative direction. But when we're dealing with something that is a little bit more different, like your vectors here, you got right, up, down, left, all sorts of direction, we will actually not use plus and minus signs. Okay? Because your plus and minus signs just tell you forward or backwards, positive or negative direction. Okay, that's all. So if we are solving based on this, you need to double check your maximum and your minimum and then your range. So all the values that is possible must be between these values. So you can see over here, you can get 12.6, which is between these two values. But you cannot get 2, you cannot get 14. Those are not possible values. Okay? So with that, we have come to end for your vector scalars and vector questions topics itself.